Hello students, welcome to the course of Advanced Machine Design. In today's lecture, we will discuss about the design of parts having symmetrical and unsymmetrical sections. We will discuss about the shear center and its location. We will also discuss design of parts subjected to unsymmetrical bending. Before going into the details, we will discuss about what are the different types of sections used in engineering applications. What is the role of sections in defining the shape of engineering structure? So basically, in engineering, we are having uh, primarily two types of shapes, and they are called symmetrical section and unsymmetrical section. Symmetrical sections are the sections which are having axis of symmetry, either x-axis or y-axis or both the axis. So it may be circular, it may be rectangular, it may be T section, channel section or I section. So you can see there is a axis of symmetry in all these shapes, and these shapes will define the type of engineering structure. Similarly, in case of unsymmetrical sections, we are having L-type section and other sort of sections which don't have any kind of axis of symmetry. In case of symmetrical sections, we generally say that the plane of bending is coincident with the plane of the symmetry or the axis of the plane of symmetry of the beam, and that's why it is very easy to find out the flexural or bending stresses using our conventional formulas of bending theory, such as sigma upon y equal to m upon I, and you can see the distribution of stresses, either stress or strain. You can see the variation of stresses across the section of the beam. So it is very easy because the bending moment plane is coincident with the axis or plane of symmetry of this section. So these are some of the examples of symmetrical and unsymmetrical bending, where you have in case of this figure A, you have symmetrical I sections, and bending is taking place about the symmetry is axis of symmetry, that is YY axis, and it is a case of pure bending. If you refer to case B, where the load is applied at an angle alpha to the YY plane, YY axis, which is the axis of symmetry for this rectangular section, and this is the first type of unsymmetrical bending. If we consider a case C, where the load is applied along the axis YY, but the section which we are using is not symmetrical section. So this is the second type of unsymmetrical bending. In third case, in C section, we have applied load W about the center of gravity G of the C section, and it will also, in addition to bending, it is also creating some sort of twisting inside the C channel. So whether can we control this twisting, because we don't want our C channel to twist under the action of this load W. So to control this the effect of this W, which is producing the twisting, we generally say that if we can control the shear shear couple F1 into H, you can see here this F1 into H, we can control this by equating it to W, which can be placed at some distance from this center G, and we can equate F1 into H equal to W into E. Then certainly we will get the pure bending and no twisting in this kind of unsymmetrical sections. And shear centers are the basically the center which defines whether your section will only bend and it will not undergo twisting, and that is the point we are interested to know about as a shear center. So thank you students, we will continue further during our next lecture. Thank you.